Welcome to the evening of Python coding. I'm very happy to have two speakers for the demo today. It's Loughnane, and I hope I pronounced the name right, and Chris Alexiuk. Hopefully I pronounced the name right themselves. They're going to talk about a library called chainlit that is related to machine learning, or more specifically, the new generation of large language models that are going out there. So since they're the experts, Greg, Chris, floor is yours.
Thank you so much, Jacob. So I should be sharing my screen now. Today we're going to be talking about chainlit, and essentially this is how to build a ChatGPT-like chatbot interface, a UI for your large language model, your LLM in Python. I'm here with Chris, and we're both with the machine learning makerspace today, which you'll hear more about at the end of the presentation. We're going to kick this off by showing you the application that we've built, and then we're going to walk you through some of the cool things about chainlit. We're going to demonstrate how you can use chain of thought reasoning, how you can actually optimize your prompts, and how you can build the application that we show using a connection between archive, LangChain, and a vector database store. We'll take questions at the end. If you have questions throughout, please put them directly in the chat, and we will make sure that our team gets to them. First off, some breaking news from today, July 18th, 2023. The Hugging Face library called Parameter Efficient Fine-Tuning, or PEFT, well known in the LLM space, just released version 0.4.0. We've got a couple of key insights here and key bullet points that we want to track. Number one, we've got official QLoRa support. Now, if you, like so many of us out there, are having trouble tracking the acronyms, how to keep up with the state of LLMs, how to track things that are changing almost daily, but certainly weekly and monthly, we have a tool for you. You can just simply ask archive questions like, wait, what is QLoRa exactly? I'm not sure I've ever heard of that. We're going to go over to Chris to show you a little bit about how we can use chainlit to build an application that might be able to help us to learn brand new things after they just came out on the market related to LLMs. Chris, can you show them how to use Ask Archive?
Yeah, you bet. Yeah, absolutely. So basically what we have here is this chainlit application, which is going to let us kind of, load in some papers and ask them some questions in natural language and learn a little bit about what's going on. So the example that Greg was talking about is called QLoRa. So we can go ahead and post in QLoRa there to our search, and we'll get and chunk some articles or papers from archive. And now we can ask some questions about it. So we can ask questions like, what is QLoRa? And we can see here that it's working through some LangChain resources in order to, answer a question in natural language. And then we get this natural language output, which talks a bit about, exactly what it is, what it's doing. Some of these words are maybe a little bit out of range if you're not used to machine learning terms, but you can go ahead and zoom in on some things like, what is 4-bit quantization? And we can, we can have our model, explain to us in natural language what that means. And we can have basically conversations with the resources on archive to better learn. We also, of course, beyond just having this interface, we provide sources to which papers, this information is coming from, as well as the pages, so that we can check the source itself if we want to, a deeper dive or anything like that.
Super cool, Chris. Yeah, so that was kind of a lot, that big Ask Archive application that we just saw. Let's break it down. And The first thing that we're going to use to break it down is a tool that's built in to Chainlit, the way we actually created this user interface. And that tool is based on an idea called chain of thought prompting. This is from the original paper in 2022, not long ago. And the big idea behind the chain of thought is that instead of just giving a single answer, so you ask a large language model like ChatGPT, hey, what's the answer to this problem? In this case, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does Roger have? We can sort of break down each step of the way that is required to get that final answer. So from chain of thought prompting, we can actually leverage this idea of chain of thought reasoning. And this is built directly in to Chainlit, which is so nice. This is an example from their website that simply asks, what is the Paris weather forecast for tomorrow? How does it compare to today's? And here we see that an LLM chain is used. It has a thought. It then goes through an action, that search action that we see next in the LLM chain. And the input to that search action is Paris weather forecast for tomorrow. Of course, we would need to get the Paris weather forecast today and the weather today, compare the two to complete the answer to this question. But you can see the chain of thinking that the large language model is going through. This is a really cool feature. Using this feature can also help us to sort of dial in exactly what we're putting in, what we're prompting the LLM with. And this is the other really cool feature that we want to show you in Chainlit using our demo application. The prompt playground. So this little edit button that you'll see on the bottom of everything is a way for you to check the specific prompts that you're using, check some of the underlying context that the prompts are using to develop their output, and then actually improve them based on prompt engineering best practices. So I'm going to kick it over to Chris to show you exactly how this works for our Ask Archive application.
Greg, before Chris, please, can you explain to some people here what a prompt is?
Yes, the prompt is simply the input to the large language model. And in order to use a chatbot, you have to put something in. So you have to ask it a question. You have to give it some sort of instruction. You have to provide it with at least a sentence to finish. So the prompt could be any of the above. You want to give it some sort of prompt so that it can at least give you some sort of answer. It can't provide an output without any input at all. So the prompt is simply the input to the large language model. Chris, why don't you show them how we can play with the prompt and maybe go a little bit deeper on what the prompt really looks like when we use Ask Archive.
Oh, yeah. So basically, great question. The idea here is that we have this, the LLM has these inputs. Those inputs are text, right? So we want to be able to interface with it through text or prompt. In this case, if we ask it something like, what is NF4, for instance, and we can see that it has this kind of idea of, it gives us this output, but how do we get there? So we can actually zoom in with Chainlit through the kind of chain of thought that it has, and we can get back to the original prompt itself. And so you can think of the prompt just as text input into the model. And because of the fact that these models are incredibly powerful and they have a number of awesome, capabilities, it's actually able to do something called in-context learning. And that allows us to leverage the prompt as a little bit more than just a text input. So if we see our original prompt, right, we have this idea of saying, given the following extracted parts of a long document in a question, create a final answer with references or sources. If you don't know the answer, just say that you don't know. Don't try to make up an answer. Always return a sources part in your answer. So that's the idea of like, we are prompting the model for the specific task that we want it to do. And we put that into the model's, text inputs. But, again, because these models are very powerful, we're able to also feed in some additional context, which is a few examples of how that task might look. So we have here like, question, which state country laws governs the interpretation of the contract? And then it gives some, context, and then it gives us the final answer with the source. And this is the idea of the prompt, right? So it's a very powerful idea because of this in context learning that these models can do. And with chainlit, we're able to zoom right into the prompt level. So this is the thing that was fed to our language model that gave us our eventual response, which we can see all the way down here. At the end of the day, these are still generation models. So you can see we just generate the answer after this final token here of that new line character. But if we wanted to make changes, say we don't care if it makes stuff up. We can, if you don't know the answer, just make something up. We can play with this prompt all that we'd like, and we can make iterative changes on our application to move things to a direction that work better. And we can do that right from the prompt level in our application. So we don't have to say, go back to code, fiddle with some text. We can start iterating in this tool, and then we can eventually, when we have a better prompt, we can push that back into our application. So really, really powerful tool and ability to kind of let us iterate faster on a very difficult part of this process, which is the prompt engineering.
Yeah. And so this is one of the things that we're most excited about with this particular tool, is that all this is built in, and it doesn't take much to actually implement chainlit. And that's what we're going to start getting into now. The first piece of context to just provide here, though, is that chainlit is actually built with another tool that you should probably know about if you're getting into Python and you're thinking about building with large language models today, called LangChain. It's built with LangChain in mind. All you really need is an OpenAI API key, and you're off to the races with chainlit and LangChain. As the creator of LangChain will remind you, like, the real power of LLMs is not just using the LLM for input, output, like ChatGPT. It's when you combine it with other sources of computation and knowledge. And that's really what LangChain is about. It's about making it easy to combine with other sources, like, for example, Archive. If you want to go more into LangChain and do a deeper dive on some of the things that we'll see in the code and in the coming slides, we did a very deep dive, really great event 2 weeks ago on LangChain that really dove into all the specifics that you need to know to put together some of the things that we'll see as we think about building out a chainlit application. The great thing about building out a chainlit application for anybody that's done any web dev is that it's going to feel pretty similar. Whether you've used Flask or Fast API or Django, you're going to have to create that app.py file, and you're going to have some simple boilerplate that you're going to follow along with. And this is the boilerplate for an application with LangChain. And it's really easy to simply just run the app locally within a Docker container, or as you'll see, and as we saw Chris do, even within a Hugging Face active application space that allows it to be public so that people can play with it. Some of the boilerplate that you see here might not make sense to you if you're not familiar with LangChain. That's where I would encourage you to check out the event that we did just a few weeks ago. Things like prompt template and LLM chain are going to make a lot more sense when you kind of do a deeper dive into some of the abstractions that LangChain uses. But as we kind of get going, we realize, well, we only really need an app.py file, and we've got some boilerplate. And then what's the other thing you need? Well, of course, you can't forget the README. And chainlit does this really nice thing where it's just the chainlit.md, where you see that README on the application. So when you run the application, you can actually read about the application with a simple click. And it's also, when you deploy it, somebody will be really clear on how to use it. So it doesn't just pop up with an empty chat interface. So you can give some people some directions. So this is what the README looks like. We put it directly on GitHub, and we also, you can see it on the Hugging Face chat. So as we sort of think about the logic flow behind the application that we just showed you, it's pretty simple, but when we break it down, you'll see there are probably more pieces than first meet the eye. First, we need to specify the topic for archive to search for papers on. That's the prompt, sort of, please enter a topic to begin. That's what we're asked by the chatbot to do. Then we get the top 3 papers in PDF format. We download those articles, then we read the articles, we chunk them into small pieces. We turn those chunks into vectors, and we store those vectors after converting them through a document embedding process into those vectors in a database. Now, that vector database, this is one of those new things as well that you're going to have to get used to working with. It's also called a vector store. A lot of these companies out there are getting a ton of funding to really push this vector database type of tool forward. And the cool thing about the vector database is it searches a ton of text really, really fast. And so if you have an input, you can find similar things within your text super fast. And that's obviously really helpful when you have a ton of data. So we're going to use a vector database called Chroma DB. It's a very popular open source tool to select. And essentially, we're going to then, from that vector database, we're going to be able to ask specific questions that we can then retrieve information from the database, and we can come back with an answer in natural language. We can return those answers not just with here's the answer, but also really nicely with the location of that answer in the paper, sort of the location of the chunk that we created when we were dissecting the PDFs, embedding them, and putting them in the vector database. So this is the steps along the way. And what Chris is going to show is exactly what this looks like in code in our app.py file. So Chris, take it away.
Let's go. Yes. So hopefully you can see my screen. And I'll just zoom in a little bit here so that it should be readable. And yeah, I mean, basically the structure of this particular tool is going to be pretty straightforward, right? We have our app.py. You can name it whatever you'd like. You just have to make sure that whenever you reference it, you reference whatever you've called it. Then we have, as Greg said, our chainlit MD, which is just a README file. And we can see that displayed when we go to our app on the README tab. So you can, pretty the usual stuff here. But let's get into the actual Python itself. First things first, we've got some imports to take care of, right? So we do have, we're using a lot of different modules from LangChain, so we want to import them. And same thing with our chainlit and archive, which is the API we're going to be using to actually get the source documents. Yeah, you'll notice that we're using this kind of decorator structure. So this is the way that chainlit, is used. It's all through these decorators. So each kind of function in the application has a different decorator, right? So we have the if we just take a peek at the app itself again, right? So we have these chat messages. You can send messages. Messages will be sent. On each of those steps, we kind of can plug in with the decorator in order to modify the behavior. So in the first instance here, we're creating a LangChain factory. basically, this is what's going to happen when we initialize our application. So at the beginning of our application running, we're going to use this to create the actual, let's call it the brain behind the experience, right? So this is going to be where we create our LLM and we add any potential resources to it. We're going to use async. This is just so that we can, query resources on the web efficiently and effectively, and we don't have to hold up the rest of the application while we do it. Again, we're just async defining this kind of init function, which is all it's doing is it's going to ask the user, right, for some input, and that input is going to be the topic that we're going to use to search the archive tool. So archive is a huge repository of a bunch of research papers from all different kinds of topics. And, we're going to leverage that tool in order to get our source material. We're going to use this kind of, because we're in async land, we're going to use our awaits. We're going to use this chainlit ask user message, which is going to prompt the user to respond to some query and then collect whatever they respond with. We use that response in order to search archive using the archive.search. Pretty straightforward. We're using the relevance criteria. There's a number of different ways you can do this. Archive is a fairly, approachable kind of addition where you can search by date, search by amount of views, all these kinds of things. So pretty easy to extend this however you'd like. Then again, we just have our message that says we are working on getting this stuff done. And we iterate through all of the PDFs and we parse them out into text first. For each PDF, we're going to also parse out some metadata. We do this so that we can, provide good responses when we want to give users sources, so source material. And so we just go ahead and grab the source, which is what lets us link to the archive paper, as well as a file path and the title, so that we can display the sources accurately. Next up, we are going to embed all of that text we've just collected. So in machine learning, obviously it's easier for computers to understand numbers than it is text. So of course, we're going to convert all of our text into vector representations through a process called embedding. We do that using OpenAI's embeddings just because we're already using the API key here. So it's relatively inexpensive and quick. We're going to go ahead and use that. And we're going to just turn our documents into embeddings. This is going to let us do a couple things. First things first, it's going to let us have the computer quickly parse through all of the source material we've gathered and chunked out. And secondly, and more importantly, it's going to let us select an appropriate subset of the sources we have in order to provide only relevant information or the most relevant information to our large language model, so it doesn't get confused or hung up on kind of like unrelated information. And again, like Greg said, we are using this Chroma DB to do that. You can think of the vector database as basically just a big NumPy array or whatever you want to think of it as that we're able to do ANN or approximate nearest neighbor searches over using similarity metrics. So how close is one sentence to another sentence? After that, because we've got everything converted into that machine understandable format of those vector embeddings, we're good to create our chain. This is a chain is what it sounds like. It's just a chain of actions that are taken. So we're building a retrieval QA with sources chain. And what this means is it takes our initial query, it embeds it into a format that's compatible with our existing embeddings. It searches for relevant sources. It collects those sources in text. So when we feed information to the language model, it needs to be in text. So we collect the text from our sources, and then we put that in this context to our prompt. And that's what lets us do these things like ask it questions that it hasn't been trained on, but it can parse and understand with that added context. You'll see that we have this temperature equals 0 in the idea of language models is that they have the ability to be more or less creative, and temperature is one of the ways that we can control that. We would prefer our model to be very uncreative. We would most prefer it to just regurgitate text where possible, and so we're going to have our temperature equal to 0 in order to prevent it from thinking too fancifully. And we're going to go ahead and use that chain for the rest of the process. So we have the ability to just let the user know, hey, we found some stuff, we're good to go, and then we return the chain, at which point it's kept in the state by the application and can be used in the future when we need it. I have one more example of a decorator we can use, which is the LangChain post process. So as we talked about earlier, these models take in text and then they output text, right? So the LangChain post process allows us to take that raw response from our model and then in some way manipulate or modify it. And we're just really straightforwardly going to add some sources, collate them so that we can display it prettily to the user and add that information in a blue box underneath the chat. And so this is all just pretty straightforward code that's doing that. And that is the, we have the ability to, again, modify each of these steps in our chainlit application. And so we just do this so that we can make those sources more visually appealing and make sure users can click on the links and things like that. And then, of course, we just use our await again to send this chainlit message with the content of our answer. And then we have these elements, which are, these additional things we're going to add. In this case, it is this element of this blue text box, which is going to display as our source. And then we send that to the application right here with .send, and I'll show you an example of that that source box that we added here. So we go ahead and just use QLoRa, just keep with the theme. So this process here, enter the topic to begin. We saw that in our application file here. So this is the factory decorated function, right? Please enter the topic again. And then we see the downloading and chunking. And then eventually, when it's complete, we found a few papers. And so we can see that represented here. We found a few papers with QLoRa. Now we can ask the question. So we're going to ask, what is QLoRa, right? Just keep it simple. And we're going to get a response. And what would normally just be a text response, instead we have this, better, more visually appealing sources box that lets us, click on the link so we can go right to the paper and see what it's all about. It'll take us right to the paper where we can see it there. And that's the thing. That's chainlit, and that's how we can use it. And those are some examples of how you might use it in your applications.
Boom. Love it, Chris. Yeah. So super cool to sort of see that and how we can do that all in Python. And really, we would say this is a new emerging best practice tool to develop your UI for your LLM, proof of concepts for your MVPs. It seems to be taking the place of Streamlit as the quickest way to get something up and running related to LLMs using just a quick Python script. Streamlit is obviously fantastic. It was great. It sort of led the way. Chainlit is what we would recommend picking up today. The chain of thought reasoning and the prompt playground are really great tools to help you dial in your workflows and the performance. It's super easy to work with LangChain as well as other tools. And it's simple app.py setup for you to get going. Get that chainlit README, and it'll just pop up right locally and or in publicly in your Hugging Face space or through a Docker container locally. So that's it. Thanks, everybody. We've got the GitHub repo that will drop in the chat. We've got the Hugging Face that will drop in the chat. You can always reach out to us directly with any questions. We're here to answer any and all questions today. And we would love for you to check out our community. We'll drop the Twitter and LinkedIn socials to the Machine Learning Makerspace community here in the chat now. And our new course on LLM operations or building LLMs in production that just launched last week on Maven, which we will drop in the chat as well. We are really excited to be able to build applications with tools like LangChain and Chainlit, Llama Index, and others. We're really pumped to get a ton of people in the same place that are amped about building really cool, complex things with some of these tools. And we look forward to seeing you at an upcoming event, in our course, or in our community that we're going to open up to the public in just the next few months. So thanks again, Jacob, and everybody at Python Meetup for the stage today. With that, we're happy to take any and all questions that you have. And I guess, Salil, your hand is up. So we'll start with you.
Hey, Greg, thanks so much for the quick demo. I was wondering if you could jump in and help us understand where RAGs is a better tool to use as versus using fine tuning, and versus that just using prompts as a way to keep the answers close to what your knowledge base or what reality is.
Yeah, I think, we're a little bit outside the scope of the LLMs that we're talking about today, but definitely a good question. I'm going to actually let Chris go ahead and answer. I know he has a lot to say on this topic. This is definitely something that we cover in depth in other places, but I'll let Chris give the high level here.
Yeah, I mean, basically, right. So what we're talking about, for those who aren't following kind of the jargon, right? So we have this idea of RAG, or retrieval augmented generation. So I mean, so technically, what we're doing is not RAG as it was originally proposed in the RAG research paper, but that term's been kind of been co-opted by the LLM application space to mean, we've got our language model, which knows tons, right, and is a very well generalized tool that can parse information and deliver quality outputs. And we're adding outside context to it through that prompt. So that process of RAG is kind of that thing where, your language model has the ability to go look at some textbooks, read them quickly, and then give you a response. But the other alternative we're talking about, fine tuning, is where we actually we in some way continue training the model, either fully training it or subset train it, or there's lots of different technical things we can get into. But the idea is fine tuning is better when you're not trying to domain shift the model, right? So if we're trying to have a model that's, say, really good at doing finance topics, and we now want to be we want it to be an expert in like motorcycles, right? That's kind of where fine tuning can become very expensive, very tedious, right? So if we're trying to teach the model new things, it's going to cost a lot of compute and time to do that. Whereas retrieval augmented generation is much faster for doing that. Additionally, fine tuning is better suited when we know we have a very specific subtask that we want our model to be very good at. And it's not going to need to do kind of these general things, or the information that it's using isn't going to need to be updated, say, monthly or quarterly or whatever it happens to be. So at a high level, I would say that the retrieval process is better for faster moving data, data that is quite different from the original domain of the model. And then fine tuning is great for very specific tasks, right? So you can imagine that the base LLM is a multi-tool, which might have a fork, but it's not as good as if you made a real fork, right? So if you need a real fork for the job, I think fine tuning is where you're going to find the best performance. So hopefully that answers the question. We're able to keep everybody involved and not could throw just jargon at you. So sorry if that was a little too jargony, but there you go.
I appreciate that. That was very useful because there aren't any rule of hands around the cutting edge. So thank you for giving that clarity.
I have a question. While other people are thinking, we have our community. There's many things, many pieces of information that are terribly new. You are at the cutting edge, I must say. But you are trying to make it such that everyone will understand, and you did it beautifully. I'm amazed of how fast it works. Like what you're doing, the first thing you're getting a prompt, like let's say QLoRa, you downloaded, you asked archive, it gave you a bunch of papers. Those papers you somehow put in the database. What is the process of actually going there for? Like what model is being applied there? And because usually if we talked about fine-tuning before, fine-tuning takes hours, days, a lot of time. It depends on how big is your information. But the question is, how do you make it so fast that it actually reacts in time? Like what runs there? What kind of model?
Yeah, that's a great question. I mean, yeah. So ultimately, what's happening here is that we're using this retrieval process that we were just talking about instead of fine tuning our model. So all we really have to do is split our text into reasonably sized chunks, which is done through the LangChain text splitter, and then we can change that text into that vector representation using the OpenAI Ada embeddings model, which I've linked to, so you can read a little bit more about exactly what that's doing behind the scenes. But the idea is that it's just embedding it into some vector space, and then we're leveraging tools like approximate nearest neighbor to search for the chunks of our right. So we take say you have a PDF with 100 chunks, right? And we're asking a question, and that question is very related to or very close to 3 of those chunks. Well, what we're doing essentially is we're asking, or we're putting our query in to this embedding space, finding the chunks that are closest to it, returning those as context to the prompt, and then we're having that be parsed by our language model. So we don't have to do any fine tuning here, which is a big part of what makes it quick. And the actual embeddings models are lightweight and efficient, so they can embed a lot of text very quickly, which is fantastic news. Also, and this is not as key for an application like this, but it would be in a more production environment, right? We only need to embed text one time unless we change our embeddings model. So it's a process that needs to occur once. Then we can persist those embeddings between sessions or in a database of some kind, or vector database, and that's what's letting us do that so fast. But the basic idea is we take the input text, we chunk it down to reasonable sized, bite-sized chunks using LangChain's tools, and then we send each of those chunks to an embedding model, generate embeddings for them, and then store those and use those to retrieve relevant context to our users' queries. So hopefully that was followable. If not,
no, this is good. It's like you explain it well, and one thing that comes to mind is that you have multiple APIs running here. Like you have an API to archive to the archive library. You have an API to OpenAI. I believe you use only the embeddings there, or do you actually use the ChatGPT, which is another API? I saw that you switched the APIs between the ChatGPT, or does Chainlit do it for you?
Yeah, so we Chainlit mostly, or in this case, LangChain handles it for us. So I'm just going to share my screen for a second here to add some context. So you guys can see what I'm talking about. But the idea is that, so if we look at the distinct APIs that we're using, so the actual calls outside of our application, we have the initial search, which is done here. and that is with the archive tool using their API. Then we have our embeddings model, which is technically being called during this process, which is going to let us turn all that text into numbers. And then we are providing access to our chain. We're providing access to the chat OpenAI, which is the GPT 3.5 Turbo 16K context model. And that is another distinct API. This time, it's still through OpenAI, but we're hitting a different endpoint. And those are the three outside APIs that we are hitting during this process.
Yeah. And you can do this only in Python almost, if not only in Python, really, because not many languages have so many APIs, especially for machine learning, that allow you to do those things fairly easily. And how many lines of code do you have there approximately, just to give an idea for the people? We have some beginners here who want to learn how to do things and how complex or not complex they are. So how many lines of code do we have there? 500, 300?
Oh, no, 100. So, and 100 lines of code, yeah, 15 of which are imports. So, like, actual functional code, not very many lines.
Good. So this is good for the beginners. Now, let's see if you have any more questions.
Yeah, quick question, if you don't mind. How is the LLM process better than like using like Google search, right? Like you would get two different answers. Why is one better than the other?
Yeah, that's such a good question. I mean, the answer that I like to focus on, because it is I think the most important, is that interfacing with Google is great, but it's not really having a conversation or using natural language, right? We're talking to Google in a way that's kind of filtered through this idea that we're making a search, and then we have to look for the information and read the information, parse the information, and that's great. And there's still a lot of places where that's going to be necessary, but with this process, we're interacting with this vast storage of information entirely through natural language. We never have to come outside of the way that humans communicate to get information or to parse information. And I think that's the biggest advantage in terms of when you're using it, right? We talk to things, we talk to each other, we talk to other people, and so being able to talk to the application is just it feels a lot more natural to use, and that's why these LLM powered options wind up, from a user experience perspective, being a lot better, because it feels more natural, because we're just communicating in natural language. The other point is that we can do some pretty interesting stuff with these tools. We can have it explain it to us very simply or from a certain perspective. And that's not something that Google's going to be able to do for you as reliably, certainly not without a lot more legwork on your end.
Yeah. Yeah. And Nate, I would also, add to this that Google is you're fundamentally consuming Google content that it provides to you based on your search. So you search and then you have to go through and you just have to consume everything. But if you use, and I'd recommend trying out Bing, because you can get access to GPT-4 for free through Bing. And if you just try Bing versus Google, the Bing chat versus Google for some of your things, you'll start to notice that Bing is actually, it's not just searching and consuming data, it's also creating at the same time. So if you give it the right prompt, you give it the right instruction, it will actually create the solution that you can just search for in Google. So we're moving from this paradigm of search and consume, and then we have to sort of digest, look on Stack Overflow, figure out how to write the code, figure out how to debug, et cetera, to now we can say, hey, and I've done this recently, and it's a really cool hack for you beginners to think about, is you can say, hey, Bing, write the Python Streamlit code for an application that I want to do X. And it will actually produce all the code for you. Or you can say, hey, here's my code, debug, I'm getting this error, and it'll debug. And you can sort of take this used to be consuming only, used to be search only paradigm, and now we're layering on this generation. We're layering this in. So, the future is not Google necessarily. We may still call it Google, but fundamentally we'll be creating at the same time that we're consuming. So we're sort of flipping it on its head. And so try out Bing and do it side by side with Google and see what you come up with. The best way is to just play around and get your hands dirty with it.
I appreciate that. I'll do that. Thank you.
Yeah, you're welcome.
I want to say something about these ChatGPT. They seem to be replacing, slowly but surely, traditional searches like Google. And one advantage is it's natural language. It's not like kind of typing in a query or an API call. You could think of the Google search as like a really basic API call where you could say, include this, but not this with a dash or whatever. However, there's another advantage that I think people are I'm seeing is becoming more and more. Well, it's an advantage because it's a disadvantage of Google. There's more and more search engine optimizations. There's a lot of websites that are low quality bot sites, random stuff, and they just bubble up because they have a high search optimization. However, they're not, the chat GTP and natural language models, at least for now, seem to be pretty spam free. Like whoever's curated the data to feed into the model, they've done a pretty good job of not putting spam in. So that's a big advantage I see. I do ChatGPT search, which is similar to the tools, your tools, an improvement on that. I do ChatGPT search of like programming, like, oh, what's the API call to draw a red box and something. I'm actually doing it for cloud stuff right now, but it works general purpose. Any commonly used library. Here's a common library, NumPy or something. I need to invert matrix. What's the call? Anything like that is good for, not 100% accurate, but if it's wrong, there's a good chance you can get it to correct itself. But if I do that in Google, I get these websites. I click on a website. It says, "Oh, please log in. Please subscribe. Please, this is premium content," and that's common thing. Or it purposely is hanging the carrot in front of the horse, like, "Oh, well, we will do this. Keep clicking to get the answer." Like it's purposely talking around it to draw our attention. And there's ads and other things the ad blocker cannot completely stop. So that's a big advantage I see of these models. Like there's a data curation step when they're training it. Whoever's curating gigantic data sets that trains the models, they're doing a pretty good job of keeping the spam out.
For
It's probably
now.
because it's young for now, right?
Yeah. I mean, the business models don't exist yet for these LLMs where they've actually monetized the marketing in the same way Google has, but fret not. It's coming. And, I think the business models today are just based on buying more compute, training larger models, and trying to get people to do something with those. So it's very emergent. Let's enjoy the time that we have where we're not getting bogged down by ads, and it's not trying to even be worse about all of that. But yeah, I think.
And I think that's one of the advantages that you kind of get, so using a language like Python or getting into building these applications is that at least for the foreseeable future, all these models are released open source. We can plug them in and build these things ourselves. And so we're not having to, go through those ads. And so learning this now is going to help you remain more ad-free as they eventually find ways to inject more and more ads into the outputs.
Yeah.
Maybe we could just pay a monthly fee. Like, look, I want ad-free and all, but I'm willing to pay $30 a month for the service, and a certain number of $30 a month. I get 2,000 queries or something a month. It's about as much as a human needs a month.
Right. Yeah, $1 a day for the rest of your life. We won't show ads to you. Yeah, there's your business model, Kevin. All day, baby. Yeah. It's super interesting to think about how all this stuff evolves. Jacob, how are we doing on time?
Look, as long as the conversation is okay and you don't mind, then we can continue. The question is whether there are any more questions.
Yeah, let me have one more. For you guys, you seem pretty seasoned and everything like that. If you were to go back to being like a beginner, you can either speak to like what projects got you started in this space, or if you had any advice for beginners to just get started, where they would start. I'd appreciate that. Thank you.
It's a killer question. That's the question, Nate. Honestly, I would start at the highest level of abstraction that you possibly can. What we showed today is not a bad place to start. Can you do what we did today? If you can, boom, you're instantly out on the cutting edge. That's the great thing about everything changing so quickly right now. If you learn the right things at the right layer of abstraction, you're going to be able to build things that people want to pay for today. And you don't have to go study bits and bytes, and you don't have to go study, although you will have to study bits and bytes. We'll get into that on another Python meetup one day. You won't have to study, basic. If you know basic Python, you can get a really, really long way today. So focus on Python. Try this out. Imagine a Streamlit app and try to use Bing to write the code for the Streamlit app and try to get it to run. There are some really cool hacks, and learn Hugging Face. Take the Hugging Face course, learn the Hugging Face stack, data sets, models, spaces. If you learn Hugging Face and you can build a chainlit app with OpenAI, I mean, that's killer. And you could do that in less than a week if you just went and got after it. You'd have a pile of questions a mile long that you could then start chipping away at to really build a depth of expertise over time. But, I would start there. And you have to know basic Python, you have to know basic machine learning, but beyond that, supervised, unsupervised, basic Python stuff. Beyond that, start building. And as Chris would say, build, build, build. And I would say stay lit today, people. Stay lit. Streamlit, chainlit, just stay lit.
Oh, these are very good advices. Can you put the link again in the chat to this, because this, if any of the beginners here can just take the code over there, install the correct things on their machine, and just run it as is, you're already way behind. And there's some things there that like you have to get through, like, installing everything, making sure you have the correct versions and so on and so forth, having all sorts of stuff on your machine. Like you don't require here to have any PyTorch or anything. It's all like it will be installed automatically. Like I'm asking about the imports and all of those. You have to have it on your local machine. So
yeah, so if you're going to use if you're going to run this on your local machine, then you'll have to go through kind of whatever your process is for getting all the requirements. But I would say like the easiest thing to do, right? So Hugging Face offers kind of this free compute space that you can use, and you can deploy the application there and start tinkering and building with it right in the Hugging Face space tool. And it can be as easy as just hitting duplicate space, and then you'll have it up and running. You can make whatever changes you'd like. I think that's probably, you can have it as easy as clicking one button, and now you've got your own thing that you can do. Or you can go in and you can pip install all the requirements, and it's totally up to you. You have the ability to choose from a number of different options depending on where you are and what what your experience is with the Python ecosystem. So, but yeah, it's to get this running, number of ways to do it, and a lot of them are fairly straightforward. So
yeah, so maybe the simplest way is just duplicate the space that you have offered and then create your own and then make some small changes. This is like for the absolute beginners. And then for more advanced ones, try to install it on your machine. This will take you a few days. at the beginning. But then again, you have nice tools today that can help you figure out those things. You can ask ChatGPT.
Yeah. That's it, man. That's it. It's crazy now. I mean, it's a great time to get into the game, people. Like there's nothing stopping you except you, for sure, 100%.
Any more questions by anyone?
I have a quick question.
Go ahead.
Hi, my name is Sipu. I'm actually a data scientist, and I kind of like fell into the space. Find it really exciting. Um, I've seen. It seems like there tends to be this like rabbit hole, like so many ways you could go and different places you can go, as I'm sure you know. So this is kind of to piggyback off of Nate's question earlier. I'm just curious, as someone who has experience with deploying machine learning and has some experience with NLP, maybe like BERT models and things of that nature, what would be the best way to kind of focus and zero in on what's important? And then just in terms of like courses and things that you can look at to really hone that skill. And then my second question is related to Greg, you said something to the effect of this is the time to get in. What do you see the opportunities being maybe today and maybe in the next 6 months? If you can look into your crystal ball and let us know what you think we should be like, what's our goal? What should we be aiming for in terms of building a career or building opportunities out of this new learning that we're going to be gaining?
Yeah, I mean, phenomenal question, Sifu. I think let's start with the latter because it informs the former. I mean, if you don't know what you're aiming at, you can't decide on a learning path. It's actually not possible. I mean, if all you want to do is keep up with the state of the art, you're gonna just that's not a specific enough aim. You're gonna get sick of it. You're gonna be like, what am I even doing anymore? I mean, what you want to think about is number one is if you're going to get into AI and you want to be in AI, okay, then you're basically saying, I want to learn faster than all of the robots. Okay, that's what you're saying. So first off, think of how crazy that is and think of how hard that's going to be. Like, are you committed to this journey? Number one. Are you committed to this journey of keeping up with AI? If that's truly something that you're committed to, okay, we can outline a learning path for that, 100%. And I would encourage you to check out the learning path that you can download on our course website with the detailed schedule and syllabus and prerequisites, because we are at the cutting edge. We are dedicated to do this. We're finding very, very, very few people are super dedicated to this. So that's number one. If you want to really, really go hard and do that, we're in the game to try to do that. It's not easy. It's not always fun, but we find it worthwhile. If you want to have a specific thing, which is better, you want to say, I work for company ABC and they have project XYZ. Focus on that specific project to say, I want to build this. Always focus on something to build. Don't focus on a course. Forget those damn certificates. Forget those stupid pieces of paper. Forget prestige. It's like, what did you build? What did you run into as you were building that was interesting, that you learned, that you could, like, you need to be able to tell the story of things that you built. Nobody cares about what degree you have, even if it's a PhD from an Ivy League institution. If it was 3 years ago, nobody cares. I mean, because that doesn't mean you can touch anything that came out in the last 6 months or since ChatGPT came out in November 2022. I think it's most important, you got to dial in, okay, is it a passion project you're doing? Is it a startup you want to build? Is it a project you're building for your current company or a company that you wish to work for? Out of those four things, you have to decide, okay, what do I need to build that? And that's where the learning really begins, is you start picking up tools and you just start building. And it always starts with data. Data-centric AI does not go away because of LLMs or because of anything else you've heard about. If it's a project, you have to start. You don't need 10 million data points, but you need some data. You have to be the expert on data, not on tools. What type of data do you want to be the expert on for your next project? That's as far as you need to go into the future in your mind. You can say what type of data do you want to be the expert on for your career if you want. That'll help you decide on projects. But I would say if you're just trying to find your next step, you have to find a passion project, you have to find a startup you want to build, you have to find a project your company cares about, or you have to find a project that the company you wish you could work for cares about, and start building that today. And we can help you with sort of outlining what that looks like, but it's going to be different depending on where you are and where you want to go. So, Chris, anything to add to that?
I mean,
Yeah, hi, everybody.
I think the important piece here, guys, is you just really have to. I don't know. You really have to take your whatever your interests are, convert them into some project you can build with AI, ML, whatever you want to call it, and then just start building it, and then allow that to guide what you need to learn next. You're going to hit a roadblock. You're going to hit a stumbling point. We're going to need to learn a new thing, and then you're going to have to learn it in order to get your project done and out the door. I would say, for the most part, that's going to be the most valuable learning, because it's going to be, what you learn while you're building, right? And that's what sticks with us the most. So like Greg said, just want to emphasize so strongly this idea that, learning by building is great for two reasons. Number one, you get to learn and it sticks with you. And number two, you wind up with like a thing that you have in your portfolio that you can show to employers, that you can express your skill through and express your talent through. So I think I'm going to triple click on build.
I guess one final thought, just not to cut, I'm sorry to cut anybody off, but the number one thing, I've asked lots of people this, lots of events we've done, lots of things I've moderated, I've asked lots of successful people this. What's the number one thing? I don't know what the hell I'm doing. I don't know what the hell I'm aiming at. I don't know the answer to any of your questions, Greg. What's the number one thing you should do? Well, you're already doing it. Okay, so congratulations to all of you. You're in a Python meetup today. You're joining a community of people that might care about this thing that you're trying to do too. And so you're in a place that you're likely to find like-minded people. Keep joining communities. Keep offering yourself up as somebody who is there to learn, is there to help. Be a Give First member of communities everywhere you go. Join more until you find the right one. You'll know when it's right because everything will line up. And just keep going. It will get better. It will get easier. You will find your tribe. And, you've already taken the first, maybe the hardest step. Okay, Kevin, sorry, man.
So I would just write down priorities. So number one should be coding every single day. A lot of times, if you're in transition, especially, you'll need to take coursework, read literature, those types of things. And then you're not going to get everything. I think a lot of people going to different tech coffees in town here in San Diego is they think they need to accomplish everything, like this master project, and they're just failing, they're not quite getting there. So do something like a project board. So you could just write down, where you're at with current projects, definitely post on GitHub, that kind of stuff. But you just have to keep the ball rolling until you find, you're applying to this place, you got employment, now you're working on your dream project, those types of things. But it's more like they'll see if you're an expert or if you have things going, and your chances of getting that dream job are a lot greater if they get that sense that, you'll work for code, whether, you have an employer or not.
Love it. Good stuff. Yeah.
It seems that we're switching to the next part of our meetup, where actually people are talking about things. People are itching to talk about their project. So
that's what it seems. Yeah.
No, it seems, because it's like the chat is full of it. So at this point, unless someone really has very itching questions about the demo or LLMs or anything like that, chainlit, then we're going to move on. We're going to stop the recording and move on to the less formal part. So anyone has really an
One
itching
last question for Greg and Chris, Jacob, if that you'll allow it. Thank you.
Go ahead.
So
Go ahead.
Again, this is something that Sifu had touched on, and I wanted to just tease it out. I have come into generative AI from conversational AI, and prompt engineering is something that has fascinated me in terms of how to get better results from generative AI. And I just wanted you two to jump in and give an idea from your perspective as to the shelf life for this particular domain of knowledge that is prompt engineering, and how long you think that role or how that role might even evolve, or if it will be around at all.
Chris, you can lead this off.
I mean, so that's a tough one to unpack super succinctly. I'll say this: if you mean rigorous prompt engineering, applying methods that interact with how the model is parsing inputs and actual, potentially parametric changes, then I think there's definitely a case to be made that that's going to stay around. If you're talking about more kind of input or context prompt engineering, I mean, we still have people who teach people how to communicate to people better, and people have been around for quite a long time. I can't imagine that the role of communicating with these progressively more and more complex and nuanced models is going to disappear. Because again, we've been around each other for a long time. We're still learning how to communicate to one another. So that's my thoughts on it. But I don't have a crystal ball. Can't predict the future.
Thank
so
you. I appreciate that.
There you go.
Yeah, I mean, just not to be terse, but like if you want to make $335K a year as a prompt engineer, go get that job right now. Okay. Otherwise, I think it's going to fall. Prompt science is going to fall to the data scientists.
Yeah, I was thinking more in terms of red teaming, so that like the alignment problem can be solved in a better way. So that's where like I was thinking about prompt engineering from like actually training the models to do better from the inside rather than the outside, like not context.
Super interesting discussion, Salil. You're covering a lot of ground with your questions today. Love it. But yeah, we got to pass the mic back to Jacob today. Thanks so much for the invite, Jacob. I really appreciate it.
Thank you. This was amazing. And people, and please join me. Make some noise on YouTube.
Yes, thank you, Chris and Greg.
Good presentation.
Great presentation. Awesome.
Yeah, this was great. You got your topic got our numbers back up to post-pandemic numbers. So I'm very happy. Let me stop the recording. Don't go away.